Hi, boys and girls. It's Miss Chase. Happy Thursday. I hope everyone's week is going well. Being extra comfy in your own home, getting to learn right from your couch. It's pretty convenient. But I do miss you lots, and I can't wait until we can all sit around the table together and learn like we usually do. But this will do for now. So, just looking ahead a little bit, tomorrow you're going to have the comprehension check, which is like the quiz, but it's just online instead. So, today we are refining our ideas, which means we've learned them, we've practiced them, and now we're really going a little bit deeper to make sure that we understand what we're doing and why and what it's showing, okay? So, we're going to go over two pages from your RCC book together today. It's going to be page 375 and 376. So please open up to that. Okay, if you need more time, you can pause me, but I'm going to get going. So the first question saying, use different models to find two fractions that are equivalent to 3 over 3. So right off the bat, I want you to notice there's something a little interesting about 3 over 3. If I have a shape that has 3 parts and I have all 3 of them shaded, what do I actually have? I hope everyone said one whole, right? So it's saying to show two different ways. One way that we've learned is to draw a model, right? So we can go ahead and draw a model. So it wants us to do 3 over 3. So in my model, I need 3 shapes, or 3 parts, I should say. 3 parts, and I need all 3 of those shaded. Okay, so on the side, let's just write this shows 3 over 3. Now, let's show another equivalent fraction to 3 over 3. So I'm going to use a little trick here. I'm going to start with a bar that has the same exact thing of thirds, okay? Now remember, we learned that strategy that I can fill in my shading, so I have 3 thirds. Now, I can make this be twice as many by cutting these in half. Okay? Now I have 1, 2, 3, 4, 5, 6. 6 equal parts, and 6 of them are shaded. Okay? I have to find one more equivalent fraction to 3 thirds. I'm going to let you show it on this model that we've already created. And I'm going to show you how we could break that up into even another equivalent fraction. So if I wanted to double it again, to multiply by 2 again, I could split all these up into halves, right? I could cut those all in half, but that's kind of hard to do. Another way I could cut this in half is do this. Look at that. Didn't I just cut all those pieces in half? Now, how many pieces do I have in total? Well, across the bottom, there's 1, 2, 3, 4, 5, 6. And on the side, there's 1, 2. So that means 6 times 2 is 12. So there's 12 boxes in here. And how many are shaded? 12. 12 over 12. So these two fractions are equivalent to 3 over 3, right? And I especially know that because since I know that 3 over 3 is the same thing as 1, 6 over 6 is the same thing as 1, 12 over 12 is the same thing as 1. Now I got to show another way. I'm going to use my multiplication and dividing strategy. So if I have 3 over 3, I can multiply it by a fraction with the same numerator and same denominator to find an equivalent fraction. I'm just going to do 2. 2 is easy. 2 over 2. What does this equal? 3 times 2 is 6. 3 times 2 is 6. Okay. So 6 over 6 is equivalent to 3 over 3. Hey, that's kind of funny. We already solved that one, right? I'm noticing a pattern there. Now I need to find one more equivalent fraction with this type of strategy. I'm going to divide this time. What number can go into both 3 and 3? How about 3? 3 over 3. Okay, so 3 divided by 3 is 1. 3 divided by 3 is 1. 1 over 1 is the same thing as 1. Okay? So we just found some equivalent fractions for 3 over 3 using a modeling way, drawing the picture, and we also did it mathematically by multiplying and dividing. Next one. It says, explain why you can multiply both the numerator and the denominator by the same number to make an equivalent fraction. Draw a model to show an example. So let's come up with any example. If you were here, I'd have you throw out a fraction, but instead I'm just going to choose one. So let's say we're going to start with 3/4. Okay? We're going to make an equivalent fraction, so we need to multiply that by something with the same numerator and same denominator. Let's do 2 again. 2 is easy. So 2 over 2, see what this equals. 3 times 2 is 6 over 4 times 2 is 8. Okay, so we found that 3/4 is equivalent to 6/8. It says draw a model to show the example. So let's draw a model. Let's draw circles this time. I have 2 circles. Mine are a little crooked. It's okay. We're just getting the point across, okay? Don't have to erase your paper a million times. So for the first one, I'm going to have 4 parts in my hole. A really easy way to make 4 parts is to chop your circle right in half and chop your circle in half again. Now I have 4, right? I need to shade in 3 of those. I'm not Picasso over here. I'm not making an art project. I'm just shading in to show my math, okay? Doesn't need to be anything fancy. This shows 3/4. Now I need to show 6/8. Well, I know that 6/8 is twice as many as 3/4, right? Because we multiplied by 2. So here's how I could draw that pretty evenly. First, I'm going to make my fourths again. Now, I need to cut each of those pieces in half. I can do this. See how I did that? You start right from the middle in one of the big chunks, and you go through the center all the way to the end. Now I have 8 pieces. How many of those do I shade in? 6. Okay. I know you guys are probably like, wait, why is Miss Chase doing it like that? But does this, even though I jumped around, are there still 6 pieces shaded? And are there still 8 total pieces? Yes. So Doesn't matter how you shade. As long as you shade 6 out of the 8, you are correct. Okay? Pause me if you need to catch up. Otherwise, I'm going to keep moving. This says Fia needs 3/4 of a cup of brown sugar. She only has a 1/3 cup measuring cup and a 1/8 cup measuring cup. Which one should she use? So, Fia's in the kitchen baking. She needs 3/4 of something, but she doesn't have a 1/4 measuring cup. So she's going to need to find an amount that is equivalent to that, given the measuring cups that she has. So she has 1/3, and she has 1/8. I'm going to write those down. Now, I need to see if I can get either of these to be equivalent to 3/4, okay? So, could I multiply 1/3? This is a strategy I want to show you. Well, okay, so I want to get to 3/4, right? I have this option and I have this option. I want to know which one is going to be easier for me to get the same denominator, because the denominator is what I'm going to look at first. So, could I make an equivalent fraction of 3/4 to get a denominator that's going to be 3? Can 4 go into 3? No. Could I somehow make a fraction that has the same denominator as the 8? Can 4 go into 8? Yeah, it can. So I can do this. 4 times what is going to give me something with the denominator of 8. So 4 times 2 is 8, right? Whatever I do to the bottom, I must do to the top. 3 times 2 is 6. So Fia could use the 8th measuring cup, and she would need 6/8 of that cup. Okay? Just circle it in the problem too. That one's a little bit tricky, and we're going to come back to that one tomorrow when I do a review before your comprehension check, okay? So there's a few strategies you could use. All right, so the next paper. All right. Here, you need to match the fractions with the model, okay? So this is my advice. If you see something like this, first figure out what your model is showing. Here, in A, I have 1, 2, 3, 4 pieces shaded. And in total, how many parts do I have? 1, 2, 3, 4, 5, 6. That one shows 4/6. In this one, I have 1 piece shaded. There's 2 parts in total, so it's 1/2, or we say 1/2. In this one, how many are shaded? 1, 2, 3, 4, 5 are shaded. And there's 6 pieces in total. 5 out of 6. In this one, 3 I see are shaded. How many in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3/12. Now, couldn't be that easy, right? It's making us find some equivalent fractions to these, okay? I'm going to start off with the easy one that I think. I'm going to think of 1/2. Because I know what halves of these numbers are. So if I look at 10/12 here, and I'm wondering what would be 1/2 shown with 12ths. What is 12 divided by 2? Is 6. So if I had 1/2 and I wanted that to be shown in 12ths, it would equal 6/12 because 6 is half of 12. Okay? So that one doesn't work. How about 6/10? Is 6 half of 10? No. 5 is half of 10. How about 1/4? Is 1 half of 4? No. 2 is half of 4. How about 3/6? Is 3 half of 6? Yeah, because 3 times 2 is 6. So these two are a match. Oops, sorry, I went to the wrong one. Okay, not that one. Made a mistake. 1/2 is equivalent to 3/6. Okay, got that one out of the way. How about 4/6? So I'm wondering if any of these have a denominator that I could find an equivalent fraction that would have the denominator 6. So could I make an equivalent fraction for 1/3 to be 6? Yeah, I could actually, because I know 3 can go into 6. So I'm going to do 1/3 times something equals something with a denominator of 6. Because I'm trying to see if it's the same as that. So 3 times what is 6? 3 times 2 is 6. Whatever you do to the bottom, you must do to the top. 1 times 2 is 2. Oh, darn. I was close. But 1/3 is equivalent to 2/6. So it's not quite. Are there any others with denominators that can go into 6? Oh, how about 2/3? Let's try that. You can write on your paper wherever you have space, but I don't want to confuse you guys too much, so I'm going to write over here, okay? So if I have 2/3, and I'm wondering what I can multiply that by to get something with the denominator of 6. I already know 3 times 2 is 6. Whatever you do to the bottom, you must do to the top. 2 times 2 is 4. Yay, that one works, right? That's what we were looking for. So that means 2/3 is equivalent to 4/6. All right. Here, I have 5/6. So I'm wondering which one of these is equivalent to 5/6. I want to look at those denominators that are easy to compare, okay? Like asking myself, what can go into 6 or what can 6 go into? I already found out that 1/3 is 2/6, so that's not the same. I already used 2/3 is 4/6, so that's not the same either. So I'm looking at my other denominators here. I have a 12, I have a 4, and I have a 10. Well, 6 cannot go into 10 evenly. 6 cannot go into 4 evenly. Can 6 go into 12 evenly? Yeah, it can. So I'm going to need to start with that fraction and divide. I have 10/12. I want to see, is it equivalent to 5/6? So I'm going to divide by something, and that's going to get me something that hopefully has a denominator of 6. So 12 divided by what is 6? 12 divided by 2 is 6. Whatever you do to the bottom, you must do to the top. 10 divided by 2 is 5. Oh, looky there. That's what we were looking for, right? So 5/6 is equivalent to 10/12. Draw the line. Okay, now the fractions I have left are this one, and this one. And I'm looking at 3/12. I might want to do a visual thought process for this one. I'm thinking, okay, let's pretend like they didn't scatter those all around, these 3. What if there was 3 in a line, in a column like this? That's a little easier for me to see. If I'm going to pretend like these are all columns and one of them is shaded, that gives me 1, 2, 3, 4 parts with 1 shaded. So, do I have anything that shows 4 parts with 1 shaded? I do, 1/4. So 3/12 is equal to 1/4, okay? There's a lot of different ways you can do this. If this visual way is easier for you than doing the calculating, you can definitely do that. I could have also looked at this 5/6 one and split these all in half to see that it was also 10/12, okay? There's really no right or wrong way to do this type of problem. You just have to work through it, okay? All right. Once again, I'm going to give you the magical opportunity to cross out part B. You don't need to worry about that. Okay? Part 5, explain why 3/4 is equivalent to 9/12. We're just going to do it, okay? So I have 3/4. I want to multiply it by something that's going to get me 9/12. Let's see if we can do that and solve this puzzle. 3 times what is 9? If I'm not super comfortable with my division or with my multiplication facts yet, I could always do this. 3 times what is 9? I'm going down the 3. I find 9. Come over. Oop. 3 times 3 is 9. 4 times what is 12? If I'm not super comfortable, drive down my 4, go to the 12. How many times? 3. 4 times 3 is 12. I know this is correct because I want these numbers to be the same, right? I was double checking the math just to make sure they weren't trying to trick me, but it's correct because 3 times 3 equals 9, 4 times 3 equals 12, and this fraction has the same numerator and same denominator. Okay, boys and girls, so that's your math instruction for the day. Please take a look at Mrs. Alder's page to see what else you are responsible for. Have a good day.